Hey everyone, welcome back to the shop. I'm Rob, and in this episode 2 of the laser cutter build series, I'm going to be figuring out how to turn this chunk of aluminum into a functional laser etcher head. The last episode was the introduction, where I covered everything I'm going to be using here and the 3 main tenets of this build. If you want to watch me yap on about that for 25 minutes, go watch that video. Otherwise, let's get on with the build. Okay, like I said in the previous video, the first thing to do is to figure out the overall focal behavior of the laser itself. This will let me know exactly how I have to set up the Z-axis sort of mechanism, how much space I have to play within there, and it will tell me exactly how this is going to fit in the base of the actual head itself. So the experiment itself is super simple. I have the laser itself in this little V-block here. I have the edge lined up with the actual edge of the copper housing. And then I'm just playing with the lens in front of that, because I still have to have access to it on the laser itself, so it's not going to be recessed inside. So copper housing is where I want to measure from. I've got my little rule right here, running power from the power supply here, and this is sort of my backstop, a kind of diffusive impervious material to allow the laser to do what it's gonna do out of the range I'm experimenting in. So, playing with just random piece of card within the range here. Got my glasses. You can see it just starting to laze there, right around 100 milliamps. So yeah, let's get on with this. First up, the longer focal length. I'm just going to be using a flat piece of card for the testing here. It's easy to focus on this dull metallic surface. In fact, it was so easy, I may actually just use a Scotch-Brite's aluminum sheet for the final product. Just lay it on whatever I'm cutting. Using the current limiting dial on the bench supply to change the power here. Each time I turn it up in this video, it's going from that 120 milliamps up to probably about the 350 milliamp range. This longer focal length cuts pretty quick and clean, as you'd expect, and was obviously more tolerant of Z-axis variability, greater depth of field. There's a larger curve than I'd like, but it may just need more focusing. I really needed welding glass as well as the laser safety glasses to actually focus that. It was really bright even with the glasses on. The shorter focal length is a lot more intolerant of focal issues. You've really got to nail the focus on it. You can see it's significantly more in and out here. It was also obvious while I was burning that it wasn't cutting into the card as deeply. I had to do some sort of deliberate Z-axis layering in a separate experiment that I tried, just going in a straight line. The etching at 1 inch is clearly much finer than at the 4 inches, and I think the actual resolution of the dot does change depending on the focal length. But I'm hoping I can still improve the larger distance results in the final testing, because that wasn't great. Now the results weren't quite as perfect as maybe I'd like, but you're just never going to get CO2 tube results from a diode laser. It's just not going to happen. So within the context of the machine that we're actually building, sort of within that scope, I think they're pretty solid results. I don't know if I would necessarily like to push it all the way to 4 inches on the cutting. Probably more like 2.5, 3 maybe. Just the curve at that 4-inch point was kind of wide. I don't think the optical system is quite optimized for a range of focal lengths. But for the etching and the sort of the pyrography side of things, that sort of 1-inch distance was pretty solid. So while I was doing that, I put together a short list of the required features of the head, sort of everything that would go into it and everything that we're going to have to figure out how to play off against each other and fit into that sort of compact space. So first up on the list of requirements is a really obvious one. Funnily enough, a laser head has to hold the laser. I'd argue that this one also includes the thermal mass, the actual volume of aluminum that's pulling the heat out of the copper housing and eventually passing it on to whatever cooling systems we're looking at. 2 is another obvious one, specifically for this build, which you'd be aware of if you already saw the first video, and that is holding the linear shaft and the lead screw. I went over why that would be the case in that first video. You'll see later in this video exactly how that's going to play out. Now, the other 4 are sort of in addition to these. So, number 3 is space for a fan. The fan that I've got that we'll be using is this 40mm Noctua fan. It's exactly 40mm around the case, and the hole spacings are 32mm. So it's ideal for going onto the 50mm cube housing. I specifically want to add a fan in addition to the air system because I may not always want air assist, or it may be inconvenient to hook up the compressor for whatever reason. I want some kind of heat removal system that doesn't rely on external systems. 4 dives into the thermal mass element a little more. So we've got heatsink, and then we've got 3 options under that. Thermal mass, as we've already discussed up here. Like the actual ability to take the heat away from the laser. Conductivity. So the ability to absorb it or the capacity to absorb it and the ability to actually remove it. And airflow. This is going to be the trickiest one because we have multiple airflows between the 2 systems. And while we're on, we'll add radiativity. That would include things like, well, ideally anodizing the outside, but in this case it could just be painting the outside black. Conductivity did equally apply to conduction to the outside as well, so that would be something like heatsink fins to try and move the heat into the surrounding air. Now, number 5, we have air assist. So this is gonna be some way of fastening to the bottom of the housing, some way of getting air into here to come out against what it's actually burning. This is going to be a tricky one. I've thought about it on and off for a few days now, and there are a whole bunch of different options, and I don't really like any of them, so hopefully something pops up while I'm working on this. The main thing with this is ideally you need a space either within the head itself or immediately adjacent to the head with plenty of airflow volume, a positive pressure chamber. You want to maintain positive pressure so that this in here is at a higher air pressure than everywhere out here, to ensure that basically smoke doesn't travel back up to the lens. That's the main issue on that. It doesn't specifically help the cutting, it's just a byproduct of maintaining pressure in there. Then I have a sixth one, which is lightweight, just to help the stepper motors out, but that is kind of a product of however it turns out. We shall see. That's it. Now I have to look at each of these, or some of these, in more specific terms.
On second thoughts, I'm going to skip that and go straight into this part. I've spent the last day or so trying to come up with the best possible solutions given the various limitations, and I think this is going to be the best that's reasonably feasible to do, especially given the relatively small scope of a project like this. So, this is what it looks like. Not super complex, mostly just drilled holes, a couple of board faces, and obviously an actual drill pattern here. But in general, it's probably not as complex as it may look. So, drilling into each of those requirements that we were just looking at. The first one being holding the laser. Well, that's obvious, it goes in right there. And the cord runs out right here. I may have to add some kind of silicone gloop in there to seal it up, I'm not sure yet. Depends how pressurized this area gets and if it seals against this face or not. Holding the shaft and the lead screw, that's obviously these three holes right here. They go down, I believe I did 30 millimeters, possibly 25, but basically about an inch should be all that's required for an actual like solid hold on those. In all likelihood, I'm just gonna epoxy them in. I could screw in like grub screws from the sides, and that's actually what I had on my original paper diagrams as I was playing with ideas. But obviously there's nowhere to get any kind of grub screw into the actual lead screw hole, and I think it's just going to be easier all the way around just to glue them in place permanently. For that I can just use Loctite super glue or the red thread locker or something like that. Given the actual surface area inside there, I don't think it will have any difficulties holding. Space for the fan, well, you can see the space for the fan, that's this right here. I measured, and it was not only 40 millimeters side to side, it had these little 2 millimeter corner radii. I added those in. I'm not sure if I can mill them or not. I don't think I have a 4 millimeter cutter, but I figured I'd put it on the diagram just because. This little area behind it is actually specifically there to allow it to sort of develop a low pressure region. Because it can't, obviously, due to all of these other holes getting in the way, it can't have a continuous airflow across the entire cross-section of the fan. I'm going to sort of even out the airflow and keep it as high as possible by having this region that allows the fan to sort of spin up and maintain suction, almost like the tanks on a vacuum former. So this low pressure region here will draw air through these 8 holes. These are deliberately placed just so you can just about see there. In each of these spots, the actual copper housing of the laser diode itself should just be poking through. So a certain element of the airflow will actually be influencing the copper itself. And it also keeps them all nice and close to the copper housing, so it's drawing the heat out of the aluminum where it really needs to be. I don't know if my concern about sort of thermal runaway is founded or not, but I think that laser diodes tend to run relatively hot, and I don't want to shorten its lifespan unduly. This borehole here is not really for anything. There was originally one there for another idea that I had, and then I just left it in because it seemed like it might come in handy at some point. These screw holes that run all the way down are actually for the compressed air fitting, which I don't have here, but would be a cylindrical object. Let's see. Then I'll have a wall. Something like that. And then go with 1 millimeter. And then maybe a 1/2 inch. We'll go with a 1/2 inch, whatever. Alright. So we'll stop that and come back to this. We'll extrude that down 5 millimeters. Nope, don't join. New body. I'll try that. Alright. And this part extrudes up. So it goes maybe not all the way up to the top, but seats it pretty firmly. Okay. I'll make sure that's join. What have we got there? 15 millimeters. The copper's up here somewhere. That's 8 millimeters. So yeah, we'll go with 15. That makes this about an inch. There it goes right here. We can chamfer it. That looks good. Okay. And we'll chamfer that too. Not too much. Alright, and then we'll go back to shaded with hidden edges. That all looks right. We can probably extrude that bit down some. Just for kind of decoration. Okay, now, and in fact, change my mind on this. Let's do another circle, like right, 3 millimeters, yeah, 3 millimeters, 1/8 of an inch, that should do it. And then this should extrude all the way down to, let's say right around there. The more volume you have inside here, the more volume of pressurized air that you're holding, and the more consistent your airflow is going to be. Let's see. We'll change the size on that. We'll make it like 8. No, what was that? 12 millimeters. We'll make it. No, yeah, we'll make it 8. All right. Stop the sketch, and that'll be bigger. There we go. Oh yeah, that'll change this chamfer. Let's double check that. That looks good. Where are we on that? Keep it 4 millimeter. There we go. Okay. So essentially, this is what would be fitting on the bottom of the head itself. Let's separate those out, 20 millimeters, okay. Like that. And then the air seal is going to be around here. These two edges, possibly even with some kind of light pneumatic oil or something, just to make that seal. And then these holes in here, of course, wouldn't actually be through holes. Well, they could be through holes, but they could also be actual tapped holes. And then the M3 screws would run through here and then screw into this. Or it could just be bolted on, that might be easier, either way. So that's the air supply. That's really the only way of doing it within the constraints required by the fan. All of these holes in here have got to go somewhere. And there isn't really anywhere for the compressed air to go without adding external components. So that's that bit. On the heat sinking ability part that I did, well, obviously you can see the fins on the outside. These are more illustrative than anything. I don't know exactly what they're going to look like, if they're going to be that size or not. But that kind of works for now. Oh, and obviously this little hole here, feeding into this little hole here, would be the compressed air input. This would be threaded and some kind of air fitting put on the outside. In terms of thermal mass, I've really tried to keep as much of the aluminum in there as possible. Like, all down through here is still pretty solid. Around here, I've chopped these two corners off, but that's more just for ergonomics. I want to be able to get my hand in there and manipulate these two. Obviously, there would have to be two. There'd have to be a short one and a longer one. Maybe the longer one would be, I don't know, 2.5 inches long or something. These two air adapters. And of course, if you're not using the air, then it could just be run without one of these on, and you would just have the actual laser, that G2 lens sort of sticking out right here. And then in terms of the conductivity, obviously this can all be painted black. I have the PC, the CPU heatsink gloop for the inside there. And then we've got the airflow coming through from the back. So that's it. I think that's going to be the way it goes. I'm not holding myself like completely stringently to this, but this is the general design. It's not too complex to machine, and it's relatively straightforward to manually machine. It's not some crazy CNC only design. So that's the way it's going to go. I guess with that, let's actually head down into the shop and try and make it.
Or maybe not. Since this video is already creeping up on the 30-minute mark, I'm actually going to cut it off there. Yes, it's another talking one, but I think it was kind of important to go over the part that's sort of doing everything and has so many design inputs into it, where the rest of the machine is kind of like every other CNC machine or sort of 3-axis CNC build out there. The only difference being that it's going to be a little more of a scratch build than those, but there shouldn't be too much to explain going forward. So, putting a pin in this one here. Next video is going to be in the shop. We're going to start the head, and that sequence of 4 videos that I showed you in the last video, the head, the gantry, the frame, and the electronics or programming or whatever it was, that should be how it plays out from here on out. So if you want to see what this whole thing is about, watch the previous video that laid the groundwork for the whole project. Otherwise, make sure you subscribe to get the next video, where we will be in the shop and doing actual machining. If you've made it this far, thanks for watching, and I'll see you next time.